Another way of describing the distribution of data is with quartiles. Quartiles are equally populated 1/4 segments of the distribution. So let's take this set of numbers. I've got 12 numbers here, 10, 21, 33, 40, 41, 53, 59, 78, 84, 85, 92, and 98. I can divide them into 4 equal parts. And this is going to kind of give us an idea of how we calculate our quartiles. But you'll notice there is no number that falls exactly in between each of these. And so how we calculate it is really dependent on how many numbers we have. And so there's a method that we're going to learn, but it's important to know it's not the one true method. People calculate quartiles differently. There are a few different methods that people use. You can check out the Wikipedia page on quartiles to actually see the different methods. The one we're going to focus on is the one that Google Sheets uses. So there's a function in Google Sheets called quartile that takes the set of numbers and which quartile number you're talking about. So our quartile numbers can be 1, 2, or 3. That's where each one of these divisions would fall. So that's what we're putting in for the quartile number. How Google Sheets calculates this is a little complicated though, but I do think this method is the best method of actually calculating the quartiles. I think they settled on the best one. So here's the steps for how to calculate this. The first thing we have to do is get the index number, meaning we got to figure out where we're starting in our set of data. So we've got all of our numbers all lined up in order, and we got to know where to start. So the index number is going to be n minus 1 times the quartile number divided by 4, all plus 1. Looks kind of complicated, but it's not, I promise you. We have 12 numbers here, so n is 12. And let's look and start with the first quartile. So Q is going to be 1. We want the first quartile. So 12 minus 1 is 11. We're going to multiply that by 1 divided by 4, which is 0.25. 11 times 0.25 is 2.75, and then we add 1 to it, and we get 3.75. That is our index number. It tells us that the first quartile lies somewhere between the third and fourth value. And actually, it's telling us it lies 75% of the way between the third and fourth value. And so that's what we need, our third and fourth value. And with that, we can find the quartile value. So we find our remainder in our calculation for the index. So our decimal places is what we're looking for here, which is 0.75. So 3.75 minus the whole number, which is 3, gives us 0.75. We want to take our third value here, which is 33, and we're going to plug that in, and then we're going to add to it the 0.75 times the difference between the fourth and third value, 40 minus 33. If we do that, then we end up with 38.25. So 33 plus 0.75 times 40 minus 33, which is 7, gives us 38.25. That is the value for the first quartile. That's what we would say Q1 is, or the first quartile is 38.25. Let's do another one. Let's do the second quartile. So n is still 12. Q now is 2 for the second quartile. So we have 12 minus 1, which is 11, times 2 over 4, which is a half, plus 1, which gives us 6.5. So now we know we're between the 6th and 7th value. So what we need to do is take our remainder, our 0.5, and we need to use that and find 0.5 of the difference between the 6th and 7th value and add that to the 6th value. So we take 53 plus 0.5 times 59 minus 53, and that gives us 56. Here's an interesting thing, though. This is the median. This is the average between the middle two numbers. It's the same thing as the median, and that's always true for Q2. Q2 will always be the median of the data set as well. So that's a nice feature and a way to sort of double check yourself. Let's do another. Let's do Q3, just to really understand this and practice it. We have 12 numbers. Q now is 3, so we do 12 minus 1 times 3 over 4 plus 1, which is 9.5. Then that tells us we're 25% of the way between the 9th and 10th value, 9.25. And so to find our quartile value, we take our 0.25 and we do the 9th value, 84, plus 0.25 times the 10th minus the 9th value, 85 minus 84. And that gives us 84.25. So the third quartile, or Q3, is 84.25. So I said that you really can only have 1, 2, or 3. But what's nice about this method is we can actually also do 0 and we can do 4. And we'll see this come up later as well. But let's do it. Let's find the fourth quartile. If we plug in 4, then we have 12 minus 1, which is 11, times 4 divided by 4, which is 1. So we still just have 11 plus 1 is 12. So this little method, when we're looking for the fourth quartile, just returns n. It just simplifies to n. And that means we're just looking at the 12th value. We're going 0% of the way to a 13th value that doesn't exist. So we would do 0 times some value minus 98. We don't even care because it's times 0. It means Q4 is 98. The fourth quartile is just the maximum of the data set. So it just returns the highest value in the data set. If you plug in 0 for Q, you'll end up getting 10, the minimum number. But I recommend you try that on your own just to double check that you're getting it.